Okay, today we will discuss the energy in the first law of thermodynamics. Yung mga di-discuss natin with these topics includes the definition of energy and its forms, concepts of heat, work, and energy transfer. We will also discuss the first law of thermodynamics, energy balances, and mechanisms of energy transfer or from a system. Also, we will compute for conversion efficiencies. Forms of energy, the thermodynamics provides no information about the absolute value of total energy. It deals only with the change of total energy. Okay, ang mga kinocompute natin is yung mga energy involved within the system or energy that we use in a given system. We have the macroscopic and microscopic form of energy. Macroscopic form of energy, it is the energy involved with the outside of the system, which includes kinetic and potential energies. When we apply forces outside the system, it is macroscopic forms of energy. While the microscopic forms of energy is related to molecular structure of a system, may mga changes within the molecular structure of a system. For example, electrical energy, meron tayo mga transfer of electrons, while the heat energy, vibration or collision, depending on solid or depende sa state or phase niya. Kinetic energy, it is the result of its motion relative to some reference frame. Alam natin yun yung mga kinetic energy is the energy wherein the object is at motion. Kinetic energy is mv squared over 2 mass times the square of velocity divided by 2. While yung maliit na Ke, yan ay tinatawag na kinetic energy per unit mass. Yung mga maliliit na ganyan, may per unit mass base or unit mass basis siya. Which is V squared over 2, ang unit niya is kilojoules per kilogram. Potential energy naman is the result of its elevation in a gravitational field. Ito yung energy at rest. Potential energy formula is the mass times acceleration due to gravity times the altitude or elevation. Yung unit mass basis niya, potential energy, P is equals to Gz. Acceleration due to gravity and altitude. Example, a mass of 5 kg is 100 meter above given datum where local G is equals to 9.75 meters per square second. Find the potential energy of the mass with respect to datum. Meron tayong object which at 5 kg which is 100 meters above where G is calculated at 9.75 meters per square second. Kinocompute natin I or hinahanap natin I potential energy. Ito yung sample illustration niya. A 5 kg object is placed 100 meter. Kung saan itong line na green na to, yung G dito sa line na to is 9.75 meters per square second. Mass is 5 kg, acceleration due to gravity, the elevation, ang hinahanap natin potential energy, simply mgz yung formula. Direct substitution, we get 4,875 joules or kung i-convert natin siya sa kilojoules divided by 1,000. Okay, another example. The combined mass of a car and passengers traveling at 72 kilometers per hour is 1,500 kg. Find the kinetic energy of the combined mass. Okay, kinetic energy naman yung nahanap natin. Here's the illustration. Ang weight niya is 1,500 kg or mass rather. And then yung acceleration niya is 72 kilometers per hour. We're finding the kinetic energy. Okay, for computing kinetic energy, mv square over 2 or 1/2 mv square. Direct substitution natin, 1,500 kg, 72 kilometers per hour. Kinonvert natin siya into meters per second. Kaya sa dito, 1,000 meter is equivalent to 1 kilometer, and 1 hour is equals to 3,600 second. Para hindi kayo malito, consider nyo kung paano nyo makakancel yung unit. For example, itong kilometer, makakancel yan. Ayan, makakancel yung kilometer. Makakancel din ang hour. Because sa numerator, denominator, same unit cancel. And then we get 1,500 kilogram times 20 meters per second squared over 2. We get 300,000 joules or 300 kilojoules. Paano natin nakuha yung 300,000 joules? Yung unit natin ng work is Newton meter, wherein mangyayari ito kilogram meter squared per second square. Yung kilogram meter per second is Newton, and then meron tayong natira pang isang meter. So, Newton meter is equals to joule. Then, we got 300 kilojoule. Kung i-divide natin yung 1 kilojoule over 1,000 joule. A lump of ice forms an airplane as it comes into the land. If the ice hits the ground with a vertical speed of 85 meters per second, what was the height of the plane when ice falls off? Assume that friction can be ignored. Illustration, airplane, may nalaglag na ice, 85 meters per second ang velocity niya or speed. Hinahanap natin ang elevation ng plane. V, ayan, yun lang yung given natin. Height is, or Z ang hinahanap. Ang ano natin, ang principle natin when it comes to energy cannot be created. Yung first law, energy cannot be created nor destroyed, so it can be transformed from one form to another. So, yung 100%, yung kinetic, yung potential energy from potential energy, it will be converted into kinetic energy. So, ang formula natin, PE, then kinonvert natin sa kinetic energy, P is equals to KE. Ayan, P is equals to KE, wherein anong formula ng PE natin or potential energy? mgz or mass times acceleration due to gravity times altitude is equals to 1/2 mv squared or mass times velocity square. Ano yung makakancel natin? Since hindi pag gaganto, parehas lang naman, consider natin na walang pinagbago sa mass, makakancel yung m. So, ang natira lang is gz is equals to 1/2 v squared. And then, gamitin natin ang algebra. Yung g, i-transpose natin sa kabila. Pag ni-transpose natin, magiging denominator siya. So, v squared over 2g. Then, direct substitution from the given 85 meters per second square all over 2 times 9.81 meters per square second or the acceleration due to gravity. Kung directly na isosolve natin dyan, we will get 368.37 meter. So, pag in-square natin to 85 square, meter squared, second square, makakancel yung second square, then makakancel yung isang meter. So, we will derive the unit na meter. Internal energy. Ito yung microscopic form of energy in the system. Lahat ng microscopic form of energy in the system. It is related to molecular structure and the degree of molecular activity. Ito din yung tinatawag nating kinetic and potential energy of molecules. Makita natin ito kung ano yung mga movement ng molecules. Molecular translation, rotation, electron translation, usually ang electron ay sa electricity, molecular vibration, it usually happens into heat when heat is applied to solid objects, electron spin, and nuclear spin. Okay, the internal energy includes sensible energy. Ito yung gumagamit, meron tayong yung specific object has specific heat, and then it will change into temperature. The latent energy, it is the energy required for a system or for an object to change into its phase. For example, water. We know that water can be transformed into solid or gaseous form. When transforming into other phase, water requires 2,260 kilojoules per kilogram of energy to vaporize at 100 degrees Celsius. While for it to freeze at 0 degrees Celsius, it requires to reject 334 kilojoules per kilogram. Chemical energy, at a specific chemical composition, meron siyang stored energy and also the nuclear energy. Okay, the definition, the portion of sensible energy is the portion of internal energy of a system associated with kinetic energies of molecule. At higher temperature, so ito sinasabi natin, the molecules have higher internal energy because at higher temperature, the molecules of gas tends to be violent, while the molecules of solid vibrates more until in such temperature, hindi niya na kayang i-hold yung molecules with each other, nagme-melt na siya. Latent heat is the energy associated with phase change process of a system. The energy required for phase change without change in chemical composition. Yun, example natin yung kanina is water. Chemical energy associated with atomic bonds in molecule. For example ay combustion. Kapag yung carbon, pagka in-expose natin siya with heat and oxygen, yung chemical bonds will be destroyed but energy will be converted from stored energy to heat energy. Nuclear energy, tremendous amount of energy associated with strong bond within the nucleus of atom itself. It deals with the nuclear fusion and fission reactions. Okay, and total energy is the sum of all energies in the system. Total energy is the sum of internal energy plus kinetic energy plus potential energy. Small e is the total energy per unit mass, the sum of internal energy per unit mass, kinetic energy per unit mass, and potential energy per unit mass or unit mass basis. Okay, yung energy can be found in a closed system wherein the velocity and elevation of the center of gravity is constant. The change of energy is identical to the change in internal energy. A stationary system, since it is stationary, yung potential energy natin is constant, walang nagbago, so it is 0. Yung total energy niya is equivalent to change in internal energy. Yung control volumes naman, ito yung mga consider natin when it comes to control volumes. Volume flow rate of the system in cubic meters per second. Mass flow rate, ito yung formula niya. Mass m dot. Ang volume, meron mapapansin natin yung mga flow rate may dot sa itaas. Yung mass flow rate is m dot times Vp, density times area times the velocity. While the energy flow rate, E dot, is equals to mass flow rate times energy per unit mass or total energy per unit mass. Ito yung illustration niya wherein the affecting variables is the diameter of the system, the average velocity, and the density of fluid, and also the internal energy per unit mass or internal unit energy on unit mass basis. Ito naman example ng control volumes wherein magkaiba yung outer diameter at velocity niya. Magkaiba yung parameters niya sa inlet niya and then sa exhaust. It usually happens in the steam. Papasok natin yung fluid or ang yung gas Pag lumabas siya, mas mataas na yung density niya, mas mababa na yung area ng pipe, and also the velocity maybe tends to get faster, or it can be slower. Pagka ganito sa control volumes na magkaiba yung inlet at outlet, yung flow in the inlet is equals to the flow into the outlet. Di ba balance natin? So PA, P1, so rho 1, A1, V1 is equals to rho 2, A2, V2. Example, hindi ko pala na-delete to, or hindi naka-animated. An 18 kg per cubic meter of liquid flows in a speed of 15 meters per second with an area of 12 square meter. Calculate the mass flow rate of the liquid. Ito yung illustration niya. Density niya is 18 kg per cubic meter. Velocity niya ay, or area muna, 12 square meter, and then velocity is 15 meters per second. So gagawin natin yung rho or PAV para makuha natin yung mass flow rate. Okay, mass flow rate is direct substitution. Ma-cancel yung cubic meter, yung meter squared, and meter. We get 3,240 kilograms per second. Okay, another example is 2.5 meters per second flows through a 40 centimeter pipe that later reduced to 20 centimeter pipe. Calculate the change of velocity between two pipes. Assume the energy and the workflow is constant within the pipe. Kung meron tayong pipe kung saan 40 centimeter yung inlet niya, and then later reduces to 20 centimeter. Ito yung example, ang illustration niya. Given natin ay velocity of fluid wherein the D is equals to 40 centimeter. And then, ang hinahanap natin ay change in velocity. Pagka mga gantong delta V or change in velocity, final state minus initial state. So, kukunin natin yung V2 minus V1. So, bago natin makuha yung change in velocity, kailangan muna natin makompute yung V2 or velocity at the diameter of 20 centimeter. And then, ito din, you can see in this example or in this given, I converted 40 centimeters into 0.4 meter. Pwede kayo mag-convert sa given pa lang para pare-parehas na yung units. It depends upon video kung saan kayo mas convenient. Ito yung ang formula, density times area times velocity at initial state is equals to density times area times velocity of the final state. And then, yung formula ng area natin, pi d squared over 2. And then, kinancel natin yung mga like terms. Ano ba yung mga like terms? Since sabi doon, inassume natin na parehas yung mass flow, inassume din natin na parehas yung density, na-cancel din yung pi. So, kung ano yung parehas sa magkabilang side, pwede natin cancel. Cancel yung pi at the same time yung 2. So, ang tira lang ay d1 squared v1 is equals to d2 squared v2. Given ang d1, d2, v1, v2 is equals to, ito, tinranspose natin yung v2, and then itong d1, v1, d1, v1, then nilipat natin yung d2 squared sa denominator. Then direct substitution, 0.4 squared times 2.5 all over 2, 0.2 squared. Na-cancel natin itong meter squared na to pagka expand meter squared. Matitira natin ay meters per second, and then yung values niya is 10 meters per second. Hinahanap natin ay change in velocity, v2 minus v1, 10 meters per second minus 2.5 meters per second. We got the change of velocity at 7.5 meters per second. So, ang pinagbago ng velocity niya is 7.5 meters per second. Okay, lipat naman tayo sa form of mechanical energy. Ito yung energy that can be converted into mechanical work, like mechanical devices such as turbines. Ito yung flow work. Ito ay nanggaling sa Bernoulli's equation. Kung ano yung pressure ng system. Ito yung formula ng kinetic energy and then potential energy. Ito naman pagka-kiin natin, ito na yung magiging formula niya kung energy equation. Okay, example, site evaluated for wind farm is observed to have steady winds at speed of 8.5 meters per second. Determine the wind energy per unit mass for a mass of 10 kilograms and for a flow rate of 1,154 kilograms per seconds of air. Ito yung illustrations natin. 8.5 meters per second yung velocity natin or yung potential wind natin. 8.5, hinahanap natin wind energy per unit mass. Wind energy for a mass of 10 kilograms and wind energy for a flow rate of 1,154 kilograms per second. Una is compute natin yung wind energy per unit mass. Ano ba yung wind energy? Wind energy is kinetic energy. So we get the formula of kinetic energy, which is kinetic energy per unit mass, or yung small e is V squared over 2. Then, substitute natin 8.5 meters per second square all over 2. We get 36.13 meters square per second square times kilogram per kilogram. Yung kilogram per kilogram is equivalent to 1 lang yan. Para makuha lang natin yung unit. Kilogram meters per square second is joules. Kilogram meter per square second is Newton. Tapos meron pa natin isang meter is Newton meter is equivalent to joule. And then kilogram, yun natira natin dito. So joules per kilogram. And then yung wind energy for a mass of 10 kilogram. Simply yung energy per unit mass natin, i-times natin sa 10. We get 361.3 joules per kilogram. Then, kung flow rate naman, or yung energy per unit mass natin, i-multiply natin sa flow rate. So, we got 41,694.02 joules per second, or equivalent to 41.69 kilowatts. Yung joules per second ay watt. And then, divide natin sa 1,000 para maging kilowatts. Another example, determine the mechanical energy per kilogram of water pump required to deliver water pressure at an elevation of 10 meter with a pressure of 392 kilopascal. The water flows at 0.7 meters per second and the pipe has an area of 0.44 meters. So, gamit tayo dyan ng Bernoulli's equation or Bernoulli's principle. Ito yung sample illustration natin. Ang pressure niya is 392 and then ang area is 0.44, 0.7, elevation is 10 meters, mechanical energy per unit mass or mechanical energy per unit mass basis is yung formula natin. Directly substitute 392 kilopascal. Yung density ng water, standard siya or constant siya at 1,000 kilograms per cubic meter plus 0.7 meters per second squared all over 2, yung kinetic energy natin per unit mass basis, plus potential energy per unit mass basis natin is 9.81 times 10. Kung makita natin yung unit, since kilopascal, ang pressure ay kilopascal, kilonewton per square meter, kinonvert natin into newtons per square meter, minultiply natin sa 1,000 para maging like units. And then, ito, nakuha sinop na natin. Ito yung mga natirang unit. Nag-add tayo ng 1 kg per kilogram para ma-derive natin yung unit. Same with here. We get 392 joules per kilogram plus 0.245 joules per kilogram plus 98.1 joules per kilogram. Ang energy per unit mass, mechanical energy per unit mass basis natin is 490 joules per kilogram. Okay, lipat naman tayo sa heat transfer and work. When it comes to a closed system, ito yung closed system natin. Closed system ay may heat and work exchange pero walang mass flow. Ang heat natin ay form of energy to transfer between system by temperature difference. Kung mas malamig yung system natin at mas mainit ang surrounding, maya-absorb niya yung heat. Pero kung mas mainit naman yung system natin, i-reject natin niya yung heat. Okay, heat addition. At sabi natin, heat addition is transfer of heat into a system. Papunta sa system yung heat, while the heat rejection is transfer of heat out of a system. Lagi ang temperature is from higher to lower temperature. Ganun lagi yung flow ng heat. Hindi pwedeng from lower to higher unless meron tayong mechanical device na ginagamit. Ito yung example, baked potato, meron tayong mainit na meron tayong baked potato, kagagaling lang sa oven. Pag na-expose natin yan sa surroundings natin or iniwan lang natin yan sa labas, yung thermal energy ay marirelease niya into sa environment, wherein dito nagkaroon tayo ng 2 kilojoules of heat rejected. Adiabatic process. Ito yung process where there's no heat transfer within a system. Ang formula natin ng heat is, or heat per unit mass basis is heat all over M. In the later part, we will compute for the heat, yung mga MCP change in T. Gumagamit tayo ng mga enthalpy, entropy. Ayan. Ito yung example ng adiabatic system wherein totally insulated yung system. Kaya wala siyang heat transfer. Okay, example, meron tayong candle. In-insulate natin. Is a candle in an insulated room. Pag sinindihan natin yung candle, over time, iinit yung surrounding. Because the stored energy or the chemical energy in the candle will be converted into heat energy. Same with electric oven. Yung heating element natin, nag-heat siya para ma-heat niya yung surrounding. Okay, ito yung mga nangyayari or ito yung mga process of heat transfer. Conduction, convection, and radiation. I'm sure familiar kayo dito. Conduction is transfer of heat from one point to another in a solid body or in an object with physical contact. For example, ito, natin yung metal rod. Ininit natin yung dulo or yung isang side. Magkakaroon siya ng conduction. Over time, mararamdaman mo na umiinit yung dulo. Kung makikita natin dito sa arrow, at this point, hinit niya. And then, magko-conduct yung heat towards here. So, you will feel the heat. Magko-conduct yun yung conduction process. You will feel the heat. Nagko-conduct yung heat sa kamay mo. Or dun sa kamay. In a convection process, it is transfer of heat from one point to another within a fluid. Kung makita natin dito, molecular motion yung flow ng tubig. Because the fluid, yung principle niya, warm fluid rises and cold fluid goes down. kapag pagka hinihinat natin, di ba, tumataas yung temperature dito sa ilalim or tumataas. So, ang tendency, mag-rise yung fluid na yon. And then, yung mas malamig na fluid sa taas, bababa. Usually, yung mga aircon sa taas nilalagay para yung warm air sa taas ay nakukool niya pababa. Ito yung continuous flow. Warm air ay nasa taas, cold air ay nasa baba. Kaya usually kapag hinahawakan natin yung mga flooring ng isang building or ng isang room, malamig. Mas malamig siya compared to ceiling. Radiation naman is transfer of heat through electromagnetic waves. For example, yan, nararamdaman ng kamay yung init ng bonfire through radiation. Same with microwave ovens, ganun din. Hindi siya direct na hinihit pero yung hindi umiinit yung buong loob ng oven pero mas umiinit agad yung pagkain when it comes to microwave. Energy transfer pag work, ito yung may ina-act tayo na force within the system. Work per unit mass basis is small w equals to w work done all over given mass. Meron tayong tinatawag na positive and negative transfer in the system. Pag positive heat is transferred, meron tayong tinatawag na positive and negative energy transfer. Pag positive energy transfer, ang heat ay ita-transfer sa system. Papasok yung heat sa system. Pagka naman work ang pinag-uusapan, work is done by a system. Yung system ang nag-exert ng work. And then ang negative naman is heat transfer from a system. Nanggaling sa system, yung heat palabas. And then, ang work is done on a system. May external forces applied to the system. Magkabaliktad siya when it comes to work and heat. Ito yung formula when it comes to change in volume in a closed system. Change in volume is V2 minus V1 or delta V. Electrical work naman, lipat tayo sa electrical work. Electrons is crossing the system within the boundary. Meron tayong electron transfer within usually metals wherein electromotive forces are doing work. Ito yung example ng formula or example ng illustration ng electrical work natin, wherein electrical work or W na may dot sa taas is equals to VI voltage times the current or I squared R or V squared over I. Nilagay ko lang dito sa gilid yung equivalent unit ng volts, ampere, and ohms para malaman natin paano ito naging kilowatt or watts. Pag watt kasi ang unit ay joules per second. So VI, ito, joules per coulomb times coulomb per second, makakancel yung coulomb, magiging joules per second. Same with I square R, magiging C squared all over S squared, makakancel yung C squared, makakancel yung isang S, matitira ay joules per second. Same with V squared over R. Joule squared, coulomb squared all over joule second, coulomb squared, makakancel to, coulomb, makakancel ang isang joule, ay matitira ay joules per second. Example, electrical work. An electric current of 20 amperes flows continuously to a resistor of 30 ohms. What is the power input in kilowatts? Given natin 20 amperes. Then, resistance natin is 30 ohms. Required is power input or electrical work flow. Kung matatandaan natin yung formula niyan, given ng current and resistance, I square R yung gagamitin natin. Ayan. 20 amperes squared times 30 ohms. we get 12,000 watts or 12 kilowatts. Ito naman yung flow of energy boundary work. Ito yung formula. Workflow is then pressure per unit mass times no. Okay, lipat tayo ngayon sa flow work. Flow of energy done by pushing fluid across the boundary in or out of the system. Workflow natin is pressure times volume. Dahil yung unit natin, ang mangyayari dyan, matitira natin yung unit, when it comes to unit, pressure is Newton per square meter times cubic meter. Maka-cancel yung square meter, matitira yung Newton meter or joules. Workflow, change in flow work is P2 V2 minus P1 V1. Ito yung example natin. Steam enters the isothermal system. Push natin at isothermal, no change in temperature at 200 kilopascal and leaves at the same mass flow rate at 180 kilopascal. Determine the flow work in the system if the volume of the steam of inlet and discharge is measured at 14.3 cubic meter plus 16 cubic meter respectively. Illustration natin. From 200 kilopascal, it changed to 180. And then yung volume natin ay from 13.3 cubic meter changes to 16 cubic meter. Given natin is 200 kilopascal. Then, nahanap natin ay workflow. Paano natin ko-compute? Okay. Ang workflow is equals to the workflow outside palabas or yung final state minus initial state. P1 V1 minus P2 V2. Direct substitute natin. Okay, ang 180 kilopascal or kilonewton per square meter times 16 cubic meter, 200 kilonewton per square meter times 13.3 cubic meter, we got 220 kilonewton meter or 220 kilojoules. Mechanical forms of work, mga requirements for a work system, there must be para masabi nating work ang isang system, there must be force acting on a boundary and the boundary must move. Hindi work kung walang movement or walang change in the system. Yan yung example illustration. Kung tulog yung system, walang nangyari, di ba? Walang work. Shaft work is the energy transmission in a rotating shaft. Makita natin dito sa illustration, ito yung shaft kung saan nagro-rotate siya because of this piston. Ang formula natin ng shaft work ay shaft workflow shaft work rate of shaft work, or the formula natin ng shaft work is 2 pi and may that times t, or 2 pi rotational speed times torque, wherein torque is Fr. Nakita natin ito, Tf is equals to T over R, or torque is equals to Fr. Okay, ito yung illustration. Determine the power transmitted through the shaft of car when the torque is applied is 200 Newton meter and the shaft rotates at 4,000 revolutions per minute. Umiikot siya ng 4,000 RPM. Ang torque na na-apply natin ay 200 Newton meter. So, ang direct substitute natin yung formula, 2 pi nt, 2 pi times 4,000 RPM times 200 Newton meter. We get ito, 5,026,548.25 Newton meters per minute. Then, i-convert natin yung minute per second. Para natin may convert, ang 1 minute is equivalent to 1 over 60 seconds. Divide natin to sa 60. We got 83,775.8 Newton meters per second or watts, or we get 83.78 kilowatts. Basta pag may dot, it is in watts, kilowatts, we're in joules per second or kilojoules per second. Okay, elastic potential energy involves the force F deforming a solid body. Ito yung strain work natin. Meron tayong force applied on the spring or in a solid deforming body. Formula natin is WS or spring work is equals to spring constant over 2 times the square of the length of the spring at the final state minus its square on initial state. Watts, or we get 83.78 kilowatts. Basta pag may dot, it is in watts, kilowatts, we're in joules per second or kilojoules per second. Okay, elastic potential energy involves the force F deforming a solid body. Ito yung strain work natin. Meron tayong force applied on the spring or in a solid deforming body. Formula natin is WS or spring work is equals to spring constant over 2 times the square of the length of the spring at the final state minus its square on initial state. The spring constant of the spring is 10,579 joules per square meter. Determine the work done to stretch the spring by 3.78 from its free length. Ito yung example natin. So, change in the system yung ginamit natin or delta X. So, we get na yung 0.0378 square din natin siya na diretso. We get 7.56 joules strain work. Let's move to efficiency or energy efficiency. Ang efficiency is laging the output over the input. Laging mas mataas yung input natin over the output. Pero meron din naman mga system na mas mataas ang output. Pero not when it comes to energy conversion. Mechanical efficiency is a device that process can be defined the mechanical energy output over the mechanical energy input. Okay, ang symbol natin for mechanical or for efficiency is N na mahaba yung tail niya. Mahaba yung dulong to. Mechanical output all over input or 1 minus mechanical energy loss all over mechanical energy input. When it comes to fluid naman, change in mechanical energy of fluid all over the shaft. Yan. Sa shaft, sa turbine naman is mechanical energy ng shaft all over the change of mechanical energy in fluid. Baliktad siya when it comes to pump. Okay, ang efficiency natin, always, the output all over the input. Ano ba yung naging output natin? 4,000 joules of kinetic energy, and then 4,800 joules of kinetic energy ang input natin. Ang efficiency natin is 0.8333. Kung gagawin natin percentage, times lang natin sa 100, kaya nakuha natin itong 83.33%. Ito yung sabi natin kanina sa first law of thermodynamics, energy can be created nor destroyed, but it can only change into forms. Process involve heat transfer but no work interaction. In oven, for example, nasa oven yung potato, nagpasok tayo ng heat which is 5 kilojoules. Ang change in energy natin is 5 kilojoules. By analysis, di ba? Pumasok ang 5 kilojoules. So, change in energy is 5 kilojoules. From initial, from 0, for example, a constant. Okay, an example of well-insulated room heated by electric heater. Meron tayo ditong heater kung saan may input tayo na 5 kilojoules. In an adiabatic system, insulated system, the change in energy is 5 kilojoules. Wala tayong ibang in-add na energy. Okay, change in energy system is the input minus output, or the final minus initial state, or E2 minus E1. Anyway, the state of the process of the system does change. The state of the system does not change during a process. Pag walang pagbabago sa state, ang energy or change of energy is 0. Ito yung formula natin. Change in energy is the change in U, change in internal energy, plus change in kinetic energy, plus change in potential energy, wherein change in U can be M times U2 minus U1. Kinetic energy natin is MV squared, MV2 squared minus MV1 squared over 2. Change in P natin is mg times Z2 minus Z1. Mapapansin natin ang internal energy per unit mass ang nagbabago when change in U. Change in kinetic energy ang nagbabago ay velocity. Change in potential energy ang nagbabago ay elevation. For stationary system, ayan, kung stationary siya, kinetic energy is equals to potential energy. So, 0. Pero kung meron tayong change in heat, change in work, change on total energy change is change in energy is equals to change in internal energy. Ito yung transfer of energy na system in an open system. We have the heat, work, and mass flow. Mass flow, when mass enter the system, meron tayong change in energy dahil yung fluid nagke-carry siya ng energy. Ito yung formula natin. Energy na system is the change in heat energy, change in work energy, and the change in flow energy. For adiabatic system, constant Q is equals to 0. Pag sinabi natin walang work interaction, W is equals to 0. Pag walang mass flow, 0 yung i-mass natin. Okay, a rigid tank contains hot fluid that is cooled while being stirred by paddle wheel. Initially, the internal energy of fluid is 800 kilojoules. During the cooling process, the fluid loses 500 kilojoules of heat and the paddle wheel does 100 kilojoules of work in the fluid. Determine the final energy of the fluid and neglect the energy stored in the paddle wheel. Ano ba na yung mga energy na involved natin? Internal energy. Ang initial internal energy is 800. And then nag-cooling process, nag-reject tayo or Q-out natin is 500 kilojoules. And the paddle does 100 kilojoules of work. Meron tayo in-add na work at 100 kilojoules. I-analyze natin siya by illustration. Makita natin dito. Initial internal energy natin is 800 kilojoules. Nag-reject tayo ng 500 kilojoules of heat. Pero nag-add tayo ng 100 kilojoules of work. Hinahanap natin is final internal energy of the system. Okay, yung formula natin is change in U. It is equals to change in Q plus change in W plus change in E. I-analyze natin ano ba yung mga work involved within the system. U2 is equals to change in U is U2 minus U1 and then equals to energy involved, which is ang energy lang na involved by heat and work. Q out, lumabas yung energy, so negative. Pagpalabas, negative 500 kilojoules. May pumasok tayo na work na 100 kilojoules of work in the shop. So, negative 500 plus 100. And then, yan natin, i-solve natin. Negative U2 minus 800 kilojoules is equals to negative 500 plus 100, so negative 400. And then, i-transpose natin itong negative 800 sa kabila, magiging positive 800. Positive 800 minus 400, we get 400 kilojoules.